subtracting the first one, that was because 7 and 4 is 11, and the next one is because 7 is 10, and just adding and subtracting.
Correct. The formula tells me wherever my x and my y are. For the second problem, I add them and I subtract them. So I took 7 theta and 3 theta, that gave me the 10 theta. 7 theta minus 3 theta gave me the 4 theta. And the same with this one up here. The formula told me add them and divide by 2. 7 plus 4 was 11. And then subtract them and divide by 2. That's where I got the 3. All right, how about this one? What are you going to do with that 7 that's out front there? Just leave it out front. So we're going to have a 7. And then we look for the one that has cosine times cosine. The third one, cosine times cosine. So I need a 1/2. So I put a 1/2. And then I need cosine of, add them together, cosine of 12 theta, plus cosine of, subtract them, negative 2 theta. All right, now traditionally, we don't leave our answers having negatives in here. So I'm going to write my final answer as 7/2 cosine of 12 theta. What does cosine do to negative angles? This was our even odd property of sine and cosine. It makes them positive. Cosine is an even function. Here it is. What does cosine do to negative things? Cosine simply makes them positive. What does sine do to negative angles? The negative comes out front. This is an even function. This is an odd function. Tangent is also an odd function. So typically we would write this as plus cosine of 2 theta. Cosine simply kills negative signs. Questions on that? All right, how about 2? Prove this identity. What would you do? Well, typically we start with whichever side looks more complicated to us. The right side looks more complicated. All right, so on the right side, I have cotangent theta times cosine 4 theta minus cosine 6 theta equals. What can you do to simplify that? Cotangent is cosine theta over sine theta. Good. And then I'm going to use, this is actually a sum to product identity. So I'm looking for the one that has cosine minus cosine. Here's the one that has cosine minus cosine, correct?
We use the one over the right bottom left.
This one? I'm not sure how I would use that one. I think you could, if you could figure out what x and y would have to be, so that x minus y would give you the 4 theta, and x plus y would give you the 6 theta. So you could use that one, I suppose. But what would my x and my y have to be so that x minus y is 4 theta and x plus y is 6 theta? I'm not sure. I mean, I think you could figure it out. You know, try some possibilities, 2 theta and 4 theta maybe. Anyway, but I think rather I want to use this one where I have cosine x minus cosine y. Cosine x minus cosine y. All right, so according to this formula, I need a -2. And then I need a sine of add them together and divide by 2. So that's going to be sine of add them together. 4 theta and 6 theta makes 10 theta divided by 2. 5 theta. And then this one says subtract them and divide by 2. 4 theta minus 6 theta. And -2 theta. And then we have to divide by 2. Negative theta. Okay. I can take this negative and it comes out front, doesn't it? So I'm going to take this negative and I'm going to bring it way out front and combine it with this negative. And 2 negatives make a positive. All right, so I can change this to a positive and that to a positive. Good. And then what happens?
Use the product of sum.
Not yet. How about I have this sine theta up on top and I have that sine theta down on bottom. So how about I reduce those? And what am I left with? I'm left with a 2 cosine theta sine 5 theta. Is that the left-hand side? No. Crap. Now what? It's not true?
Or we just did it wrong.
Or we did it wrong? Or we're not done yet? It's a possibility. All right, so sometimes what happens with these identities? Sometimes you start with the right-hand side and you mess around with it for a while and you get to a point where you're kind of stuck. I suppose I could use the product to sum identity now, and maybe that would work. But sometimes what you want to do is mess around with the right-hand side for a while and get to a point where you're stuck, and then maybe mess around with the left-hand side and see if you can still make them be the exact same thing. So I think that's what I would do on this one now. I think I would go to the left. The left starts with sine 4 theta plus sine 6 theta. And I think I could use my formula for sine 6 theta plus sine 4 theta and see what happens. I need a 2. Then I need sine, add my things together and divide by 2. So that's sine of 5 theta. Hey, that's looking good. I've got a 2, I've got a 2, I've got a sine 5 theta, I've got a sine 5 theta. Finally, I need a cosine, subtract the things and divide by 2. If I subtract them, 4 minus 6 is -2, divide by 2, -1. But then what does cosine do to negative signs? It obliterates them. 2 cosine theta sine 5 theta. Did I end up getting the same thing on both sides? Yeah. So that's probably the most challenging identity we've seen so far. And that happens sometimes. Sometimes you goof around with the right-hand side for a while and you kind of get stuck. So then try goofing around with the left-hand side and see if you can get the left-hand side and the right-hand side to be exactly the same thing. Lindsay? Where did the negative theta go? That went away because that's my even property of cosine. Cosine of negative theta. Theta cosine kills the negative signs. All right, let's flip it over to the back here. Tangent of x plus y over 2 equals sine x plus sine y divided by cosine x plus cosine y. Once again, looking at that, which side do you think looks more complicated?
Right.
The right. Okay. Sine x plus sine y divided by cosine x plus cosine y. Looking at my long list of identities, I got a lot of them now. What can I use? The sum of two angles? I don't think I can use the sum of two angles. I don't have sine of x plus y. I have sine of x plus sine of y. So I don't think that's a sum of two angles. Any other useful identities that you see? Sum to product. Look at what we have right here. Sine of x plus sine of y. And that's what we have on top of our fraction, isn't it? And then we have a cosine x plus cosine y. And that's the bottom of our fraction. Okay, so we'll plug those in. So sine of x plus sine of y, this is 2 sine of x plus y over 2 cosine of x minus y over 2. And then I divide by cosine of x plus y, looking at my formula sheet, that's 2 cosine of x plus y over 2 cosine of x minus y over 2. That almost looks worse. Almost looks like we made it messier. But I think it's better. Why is it better? The cosines reduce. Cosine divided by cosine is 1. And the 2's. What's left? And sine over cosine is? Tangent. So what do we have left? We have tangent x plus y over 2, which is exactly what we wanted. Questions on that one?
Where did the x and y come from? Sorry.
Where did the x and y come from?
No, just like how you got rid of all that stuff.
How we got rid of all that stuff?
Yeah.
Well, those were exactly the same.
Yeah.
So when you divide them, you get 1. Same with those. And then look what I'm left with. I'm left with sine of something over cosine of something, which is defined as tangent of the something. And that happens to be exactly what we wanted. Just kind of got lucky there. It kind of fell right out into our lap for us. All right, 2a. Which side looks more complicated? Left. All right. So sine cubed x minus cosine cubed x divided by sine x minus cosine x. Any good ideas? We could factor out some stuff. Excellent. What stuff can we factor out? All right, so up on top, there's a formula that you probably don't remember because you don't use it very often. Anybody happen to remember the formula for something cubed minus something cubed? There is a factoring formula for that. Usually people don't remember this one. This factors as a minus b times a squared plus ab plus b squared. So we're going to use this formula, and everywhere we see the letter a, what are we going to plug in? Sine of x. And everywhere we see the letter b, we're going to plug in cosine of x. All right, so this is going to factor as sine x minus cosine x times sine squared x plus sine x cosine x plus cosine squared x. And then we're dividing everything by sine x minus cosine x. Alright, well once you know that formula and once you get that factoring, this problem becomes a lot easier. Why is this problem now a lot easier? I can reduce stuff. The sine x minus cosine x reduces with the sine x minus cosine x. And what other good things happen?
Oh, that is your 1.
Sine squared plus cosine squared is 1.
And sine x cosine x is 2 sine.
So this is 1 plus sine x cosine x. And you're almost right.
And that equals sine 2. Or is it 2?
Right. In order to turn this into sine of 2 theta, it's got to have a 2 in front of it. The identity is sine of 2 theta is 2 sine theta cosine theta. So I need a 2 right here. So I'll put a 2 right there. But I can't just put a 2 there. The penalty for putting a 2 there is I got to divide by a 2 also, don't I? If I want to multiply by a 2, I have to divide by a 2. If I multiplied by 2 and divide by 2, what have I done? Nothing, because 2 divided by 2 cancels out. It's 1, right? So this is now 1 plus 2 sine x cosine x. That's sine of 2x. And I still have that 2 on bottom. Do I have the right answer? What's that? How did I get rid of cosine? I used this identity that says 2 sine x cosine x is the same as sine of 2x. I'm missing a 2 here, aren't I? But that's okay. I'm going to think of 1 as being 1 over 1. And then I'm going to get a common denominator, and I'm going to add those. What's the common denominator? 2. So I multiply top and bottom by 2 again, don't I? So this is 2 plus sine 2x all over 2. So some fun with fractions on that one. Questions on that one? Michael.
So you just threw in the 2 in there?
This 2 right here?
Yes.
Yep, I just threw it in because I needed it.
Okay.
But what's the penalty for throwing a 2 in?
Divide by it.
I have to divide by it. I can't just throw a 2 in.
Yeah.
I can throw a 1 in. So I wrote 1 in a funny way. I wrote it as 2 over 2.
Okay.
You just throw the 2 in, like for the 1. So.
Yep. So what I did is instead of thinking of this as 1 over 1, I thought of it as 2 over 2. And then I had common denominators. So 1 over 1 is the same as 2 over 2. And then I have common denominators, and I can write it as just one big
No,
fraction.
like up there, can you just like when you multiply the sine x cosine x by 2, can you just like, can you just multiply the whole thing by 2?
I could have done that, yes. Back here where I had 1 plus sine x cosine x,
Yeah.
I could have multiplied the whole thing by 2, which means I need to divide the whole thing by 2. And that would have actually worked out a little bit cleaner, I think. Because then I would have had the 2 plus 2 sine x cosine x all over 2. And then this 2 sine x cosine x, you would tell me is sine of 2x. Yep. Other questions? All right. B and C. Those are your homework problems. See, now life isn't so good as it was a few months ago. B, I'll tell you, B is really pretty similar to 2A that we did before. So that's what you're going to want to mimic on this one. And C, the trick with C is think of conjugates. You see a sine x minus cosine x, think of perhaps trying to use a conjugate and multiply and see what happens there.